Here is another video that's designed to show you or help you to see the importance of the Pythagorean theorem. In this video, we'll look at the 45, 45, 90 triangle. Okay, as we are going to look at the 45 degree triangle, first we're going to start with a square. Now we know because it's a square, we know that the length of each side is congruent, and we know, so I'm going to mark each side is congruent, and we know that the angles are all 90 degrees. What I'm going to do, let's suppose that this square has a length of 1. Then I know that all my angles have a length of 1. But my question is, what is the length of the diagonal? Let me draw that in. Now when we draw in the diagonal, what you'll notice is that we actually have two congruent triangles. And not only are the triangles congruent, but each of the two triangles are isosceles right triangles. So that tells us a lot of information. So since it's an isosceles right triangle, we know that one angle is 90 degrees and the other two angles are congruent. So because the other two angles also have to add up to 90 degrees, we know that each one is 45 degrees. So this angle is 45 degrees. And this angle here is 45 degrees, and also over here and over here. And that's how we get our 45, 45, 90 triangles. 45 degrees, and 90 degrees in our triangle. And my question was, the original question is, what is the length of the diagonal of the square? So we can use the Pythagorean theorem to find that out. So we want to know the length, and I'm going to think of that as C right here, and I'm just going to work with one of the triangles. Then since they're equal, and I know that 1 squared, well, let me write the Pythagorean theorem, that a squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared, because these two are equal because they're the two sides of a square. So I have 1 plus 1 equals c squared. So 2 equals c squared. So what is the length of c? Well, in this case, it's not going to be a rational number. We take the square root of both sides, and that I had discussed in a previous video, and we get that c equals the square root of 2. So when this side is 1 and this side is 1, then the hypotenuse is the square root of 2. I'm going to look at a couple more examples. Okay, in this example with my triangle, we know that it's a right triangle because I drew in the little corner. It signifies 90 degrees. The two legs are congruent, so they're equal, and then that gives us an isosceles right triangle. The base angles are each going to be congruent, so they have to be 45 degrees. So then we also know that this side here is going to be 5, and then I can use the Pythagorean theorem to find the length of the hypotenuse, that a squared plus b squared equals c squared. So I'll have 5 squared plus 5 squared equals c squared. So 25 plus 25 equals c squared. 25 and 25 is 50 equals c squared. Take the square root of both sides, and I get that c equals the square root of 50, which when it comes to simplifying square roots, I do have another video on that, and I'll end up with this 25 times 2 square root of 25 times 2, so C equals 5 times the square root of 2. And if we want to notice a pattern, we're just going to see how the answer, or the hypotenuse, compares to the length of our side. Okay, let's see if you've already noticed the pattern. Because in this triangle, again, it's an isosceles right triangle, so it's a 45 degree, 90 triangle. And if the hypotenuse is 8 square root of 2, I want to know what the lengths of the legs are. So they're both going to be the same. So I can call this, let's say I call this A. Then this is actually also going to be A. So then I can say that the Pythagorean theorem is A squared plus B squared equals C squared. So I have A squared plus, and instead of it being B, it's A squared equals 8 square root of 2 quantity squared. So I have 2A squared equals 64 times 2. And then I'm just going to divide everything by 2. And I get that A squared equals 64. Take the square root of both sides. And A equals 8. Is that what you guessed? Is that what you expected? So we start to see a pattern right there. If we remember the pattern, then we don't have to go through and figure it all out from the Pythagorean theorem. But if we don't notice the pattern, or we don't remember the pattern, we choose the Pythagorean theorem and we can figure it out. We don't get stuck because we have the Pythagorean theorem and we can use it. Now let's look at this example where the hypotenuse is given to be 6. And we want to find the length of each leg. Well, we know that they're the same. So again, I'm going to call them both A. So I know that A squared plus, in this case, A squared is going to give me 6 squared. So I have 2A squared equals 36. I'm going to divide both sides by 2 to get A squared by itself. And I have that A squared equals 18. Take the square root of both sides. And I get that A equals the square root of 18. And I go to factor that, I get A equals the square root of 9 times 2. The square root of 9 is 3, so then A equals 3 square root of 2. That might not be what you expect, but if we take 3 square root of 2, let's just, and if you realize that whatever we had here for a leg, we multiply it times the square root of 2, we get the hypotenuse. 3 square root of 2 times the square root of 2 gives us, the square root of 2 times square root of 2 is 2, and that gives us 6. So we are in fact correct, and our shortcut, or our expectation, holds true. One, and we have an isosceles right triangle. It's a 45 degree, 90 degree triangle. The hypotenuse is given to us to be 1. So again, we know that A squared plus, in this case, A squared equals 1 squared. So we have 2A squared equals 1. Divide both sides by 2. And we get A squared equals 1/2. When we take the square root of both sides, we get A equals the square root of 1/2, which we can think of that as the square root of 1 over the square root of 2. Well, we can take the square root of 1, but we can't leave the square root of 2 in the denominator. There'll be a separate video to show you why we rationalize the denominator. But what we're going to do, so we don't have a square root of 2 in the denominator, we're going to multiply both the numerator and the denominator by the square root of 2. And what that gives us is that a equals the square root of 2 over 2. And so when the hypotenuse is 1, then each side is the square root of 2 over 2. Because the sides are going to be congruent, or the legs, whatever you want to call them, they're going to be congruent. And so this triangle is one that we're going to use when we look at the unit circle. But the relationship, if you don't memorize the relationship, you don't have to. You can go ahead and figure it out from the Pythagorean Theorem anytime you need it. Just figure it out. It's up to you whether you want to memorize the shortcut or notice the shortcut or just use the Pythagorean Theorem and you can figure it out. It's up to you. It's your choice. I hope you enjoyed this video. Thank you.